Now to take some shortcuts here, we use something called a condensed structural formula. Because after all, who wants to write all of this stuff? In other words, where is it here? We don't want to show all of these bonds because that takes a lot of time to write all those out. So to write condensed structural formulas, we have to be aware of a couple things. First of all, we have to remember that carbon is always going to make 4 bonds. Hydrogen is always going to make 1 bond. So if we wrote out a condensed structural formula for something like octane, notice, let's go back to the octane again. How many hydrogens are attached to this carbon?
3.
This one here?
2.
2, 2, 2, 2, 2, 2, and 3. So if we were to write out a condensed structural formula for octane, it would look like this. We'd write CH3, CH2, 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 CH3. So at least we've gotten rid of all of the kind of the lines that we have to draw out. Just remembering that if we write a CH3, this means it's a carbon with a single bond out to 3 different hydrogens. There's a carbon with a single bond out to the 2 different hydrogens, and so forth. Even this is kind of a long way to write it. So if we wanted to write this in a more condensed form still, we could write CH3, then we could take CH2. CH2 is repeated how many times in here? 6 times. So we could put the CH2 in parentheses with 6 down below, and then on the end, CH3. And so this would be a way of condensing that formula down even further. So again, this here would be octane. So now, if your next step would be to write out the structural formula for pentane, let's write out the condensed structural formula for pentane. Well, pentane is going to have how many carbons? 5. Carbon on the end is going to be written with a CH3. And then we'd write CH2 how many times? 3 times. And then on the end we'd put CH3. If we wanted to condense this even further, we'd write CH3, CH2, parentheses, 3, and then CH3 on the end, and this then would be pentane. And again, the one above it here is the octane. Now in each one of these, we should remember our general formula for the alkanes as being CnH2n plus 2. So it means you can confirm that what you've done is correct by counting the number of carbons and hydrogens. So if it's pentane, it's going to have 5 carbons. Now don't count them over there. How many hydrogens should there be?
12.
12. Because we take 2 times 5 to give us 10, plus 2 more is going to give us 12. So there should be a total of 12 in there. And so if you count and go through here, you see we have 3, 5, 7, 9, plus 3 more is going to give us 12. And so it's always a way then that you can confirm that you have the correct number of hydrogens in your molecules. Now even the, yes?
Could you write CH3 in parentheses and then a 2 and then CH2 in parentheses and then 3?
And that we wouldn't do. So in other words, the question was, can we do this? The answer to that is no. When we write out the condensed structural formulas, we still want to show, we can call these kind of like bookends.
Oh.
They just show what each end of the molecule consists of, that we have a CH3 kind of on each end of the molecule. But this here just tells us that this unit is repeated
3 times.
3 times. Now, if we were an inorganic chemist, then yes, we would. But now we're an organic chemist, and as organic chemists, we want to show what is present on each end of the molecule. And so organic chemists handle those parentheses. They mean a different thing. They mean a repeating unit within a molecule when we see that. Okay? When I use it as organic chemists, it doesn't matter whether they're repeating in a line or not. It just means that that unit is repeated. Okay? Now, of course, this is still too long to write it. There's an even easier way to write these, and it's to use what's called a line formula or a line structure. So I'm going to move this down here just a bit. Put it down to about here. There we go. And again, it's to use a line formula or line structure. And again, line formula or line structure. It has a very similar premise. And that premise is that we should know that carbon is always going to make 4 bonds, hydrogen is always going to make 1 bond. And so a line structure for octane would look like this. We go 1, 2, 3, 4, 5, 6, 7, 8. That's octane. And pentane would look like this. 1, 2, 3, 4, 5. And so when we draw those structures, each end or each point here represents a carbon atom. So this would represent 1, 2, 3, 4, 5 carbon atoms. The one up above here, we count the number of points or ends. We count 1, 2, 3, 4, 5, 6, 7, 8 points on there. And that means that there's 8 carbons, and that gives us octane. And so you might see that chemists are drawing these funny little squiggly lines and everything else. In fact, if we saw something like this, hold on, I'm trying to remember what I'm trying to show you. Here we go. Boy, this is, my stylus is really bad because it does, the points don't line up. There we go. Well, we'll assume that's a straight line there. But this would tell us there's a total of how many carbon atoms in here? 6 carbons. And the number of hydrogens in here, there'd be how many hydrogens right here? 2, 2, 2, 2, 2, and 2 all the way around. And if I wanted to draw this one right here, all I would do is I'd add in this, this, and this, and we've now made this molecule. And so if we remember now, carbon always makes 4 bonds, hydrogen always makes 1 bond. If you look at this, this is a carbon atom here. This carbon atom's already making how many bonds? 1, 2, 3. The 4th bond then is going to be out to hydrogen, and the hydrogens are implied. We don't write those hydrogens, but again, we said each one of these then is going to be bonded to 1 hydrogen because it's already making 1, 2, 3 bonds to a carbon atom contained in there. So this is the way that chemists show benzene ring, like this. Okay, any questions on that there? Now, an alkyl group is basically an alkane that has had 1 hydrogen atom removed. The alkyl group is an alkane that has had 1 hydrogen atom removed. So that would be something like this. This here is an alkane, right here. Remember, what is the name of this alkane? Again, it is methane. This is methane. So if I take 1 hydrogen off of here now, this makes it an alkyl group. And this alkyl group has a name. And I'll do another one as long as I have it here. Remember the name of this one. What is the name of this alkyl group? This is ethane. If I take a hydrogen off of here, this is now an alkyl group. As long as I have it here, we'll take one more. This here is also an alkane. The name of this one is, again, how many carbons?
Propane.
This one's propane. So if I take hydrogen off of here, this now makes it an alkyl group. Now we want to distinguish between these alkyl groups, and to distinguish between these alkyl groups, we have to be able to count carbon atoms. So to name an alkyl group, here's what we're going to do. To name, we drop the A and E suffix from the alkane name, and we replace with the suffix of YL. So just like alkanes all have an A and E suffix, all alkyl groups have a YL suffix. So this alkyl group would write its formula as CH3, the dash, and the dash is there because it's going to make one bond still. What name would we give to this one? It's a methyl group, good. And this one here, CH3, CH2. And we'll show a dash because it's going to make one bond. This will be called ethyl. This here is an ethyl group. And if we look at this one right here, CH3, CH2, CH2, dash because it can still make one more bond, we'd call this one here propyl group. This here is a propyl group. Now I'm going to skip a couple lines and we'll go down to this one here. Remember the name? This is, let's count the number of carbons in this one.
8.
There's 8, so this would be called? Alright, right now it has all the hydrogens there, so it's called?
Octane.
Octane. We take a hydrogen off the end, this would be called? An octyl group. Okay, so we'd write it as CH3, CH2, 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 that's 4, 5, 6, 7, 8. This, and then the bond, this would be called an octyl group. Now, what I've done in each one of these is I've removed them from the end. When we remove that hydrogen from the end, we change the A and E suffix to a suffix of YL. We'll talk about why we do that in a moment, but I want to go back to this one right here on the propane. And on the propane, let's say that instead of taking the hydrogen off the top here on your left-hand side, let's say that I took it off of the top here on the right-hand side. Is this different than taking it off of the left-hand side? It's not different because all I need to do is flip it over. And remember that single bonds always have the ability to rotate. So any one of these positions on your left-hand side is the same as any one of these positions on your right-hand side. But it would be different if I took a hydrogen off where?
The middle.
Right off the center, exactly. If I take it off the center now, this is still an alkyl group, but it's an isomer of the propyl group, and this makes it an isopropyl group. So again, it's an isomer of the propyl group.
Right here.
We call it, thank you,
Yep.
we call it the isopropyl group. And so if we wrote it out here, it'd be CH3, CH, and the bond is off the center carbon, and then a CH3. Again, we call this one isopropyl group because it is an isomer of the propyl group. Now, once we get beyond 3 carbons, if we went to 4 carbons, or like in this case, 8 carbons, there gets to be even more isomers because I could have, instead of taking it off the end here, I could have taken off the second carbon I could have taken it off the third carbon in the chain, I could have taken it off the fourth, and they would have all been different isomers, and the naming for that gets way, and that's one of the reasons why there's a whole year-long course in organic chemistry, because there's a much more complex naming scheme to that. So the point I want to make here is that you are only going to be responsible for naming the alkyl groups in which the hydrogen is removed off of the end, with one exception, and that will be the isopropyl group. You will need to know the isopropyl group. Otherwise, you're only responsible for knowing the names if we take the hydrogen off the end carbon, with one exception, if we take it off the middle carbon in a 3-carbon group, and we call that an isopropyl group. And the reason I would like for you to know that one is because many of you may not use this on a daily basis, but you use this often. This here now is an isopropyl group, right here, because we took the hydrogen off the middle carbon. We add this on, this makes it an alcohol. And so the name of this alcohol is isopropyl alcohol. And where do you find this alcohol? I know you've heard of isopropyl before.
Isopropyl rubbing alcohol.
It's rubbing alcohol, exactly. This is the alcohol found in rubbing alcohol. And it's different than this alcohol right here, which we call ethyl alcohol or ethanol. So there are two different types of alcohols. Notice though what makes an alcohol is this OH. So again, that's something else that will be coming up.